Alright, on to kinetic energy. So we've got an ambulance, it's travelling that way at 24 meters per second, and we want to find out how much kinetic energy it's got. Kinetic energy is only found in objects that are moving, and you can see that's reflected in the formula, because the formula is EK for kinetic is equal to half mv squared. So if your object has zero velocity when it's stationary, therefore it's going to work out to have no kinetic energy. Alternatively, if your object has zero mass, it will also have no kinetic energy, but there's not many objects with zero mass. So velocity is the main influencer, and also because the velocity gets squared, it has a bigger influence on the amount of energy an object has. So we've got our object, this is our ambulance here, so it's half 2200 times 24, and the trick will be just got to make sure that you square it. And again, it's giving us a big energy value, so we'll round that one off to 630, and then we can just put it into kilojoules. Or we could put the 3 zeros in. Probably important to show that it's 2SF. Alright, that's that one. This one here is, what's happened is that the ambulance has been attacked by a monster truck. And the monster truck has landed on top of the ambulance. The ambulance driver got a fright and put the ambulance into reverse. So now he's going in reverse at 24 meters per second. So his velocity is no longer positive 24. His velocity is now negative 24. So we'll see what effect that has. We'll need to find out that energy of the system here. So we've got to include the mass now of the monster truck, because it's also sitting on top and it's also traveling at 24. So EK is equal to half mv squared, gets written down, and that's half of our mass, which is still going to be 2200 plus the mass of the mini monster truck, which is, let's say it's 1500 kgs, times 24 squared, and it's negative 24 squared. And we'll put that, one thing you'll spot is that when you square a negative, it just becomes a positive. And that's also an indication that energy is a scalar quantity, not a vector quantity. So there is no direction. So the fact that it's got a negative there does not matter. Alright, you have to remember to put that into brackets, so you're adding them before you halve them. And this is the answer you get, which it's going to round to 1.1. And we could put that in as megajoules for million joules, because we've got 1, 2, 3, 4, 5, 6 places to shift the decimal point. So therefore it gets replaced with mega. Alright, we'll throw in one bonus question. So we've got our EK, this is afterwards. The little mini monster truck has fallen off the ambulance and it's cruising along on the ground with this much energy. So 2,375 joules of energy, and its mass is still the same. We're going to now try and find out what is its velocity. How fast is it going? So we go to our formula. EK equals half mv squared. We put in our substitution. 2375 goes in as energy. Mass is going to be 1,500 and it gets v squared. Our job now is we'll just simplify before we try and rearrange. So what's half of 1500? So that's going to be 750. V squared, 2375. Now to get to make v squared the subject, we've got to divide both sides by 750. These ones get to cancel out. That leaves us with v squared will be equal to, and do this division and it gets put down here, and you'll see that we now need to get rid of the squared here. So square rooting that side and square rooting that side, gives us V is equal to 1.779. And we'll just check. We've got 4 significant figures there, and we may have 4 there, so we can just leave it at that. And write in our unit ms minus 1. And that can have a direction, and the direction it was going was that, so we could put that in as to the right, because it fell off the ambulance when the ambulance was going backwards.